Hey everybody, Mr. Brown here, and in this video I am going to show you how to graph the information for the calorimetry lab. And in this video I'm using the online version of Excel, so if you're just using your Sandhills account you can go to office.com and use this version of Excel and follow right along with me. So you have to make two different types of graphs, or really four graphs in total, but two different kinds of graphs in this lab exercise. And I've got examples set up for all four of them here. The first two graphs that you have to make should have the data formatted in time versus temperature columns, like you can see here, time versus temperature columns in my blocks here and here. And of course you've got two sets of that data, so I've got two sets of that data set up right beside each other, time versus temperature. In the second part of the experiment you will do graphs where you have mass versus change in temperature, and you'll have three data points for those two sets of data. And I have one set of data mapped out on those here, and I have the second set of data. I don't have it's blank. I don't have any examples for that, but once the video is over you shouldn't need examples for that. So I will show you how to do the graphs for both of those starting now. So if you're doing the second half of the graph you can skip to that part of the video. But for the first graph, so you should have time, and that actually says it's in seconds at the moment, and it should be, that's time in minutes. So you have time in minutes on the x-axis, and you have temperature in degrees Celsius in a y column. You are going to want to select all of that data like you see me do there. We're going to go to Insert, and we're going to use one of the charts. You can drop down the menu if you want to, or you can simply click the group of dots there. That is the scatter plot with only markers, and that's the one that we want for this graph, or this one in particular. And if we click it, our graph should look like that. And if we want to modify the graph a little bit so we know what we're looking at, we can go to the axis titles and click to display those titles below the axis. So below the axis we want to put time in minutes, and beside the axis, or beside the y-axis there, we will do the rotated title, and we will call it temperature degrees Celsius. Click OK there. And I don't like the series 1 block. I just selected it and hit delete, and I was able to get rid of that series 1 block. I think it looks better. And chart title, you can delete or add a chart title if you want to. So we need some data. We want the initial temperature from the moment that we mixed the hot water and the cold water together in our calorimeter. That's what we're looking to gather from this graph. To do that, we're going to need a line of best fit to extrapolate the time at temperature 0, what we are going to interpret as the y-intercept of our linear formula. So we need a linear formula. So we need to double click on the chart until we get the format options open for the chart. We're going to open the series 1 arrow there, and we'll need to turn on trend line 1, and we'll see equation and values. For this one we do not want to click the set intercept button. The intercept is what we're looking for. For the equation and values, we'll want to turn that on and make sure display equation on chart is shown. And if we kind of move that around, so trying to get the formula there and get it to move into a viewable spot. There we go. So if we look at our graph now, and I'll even zoom in there, the data that we're looking for from this graph in particular is the y-intercept. So that 47.6, that's what I'm going to interpret as the temperature at time 0, or the temperature of that water test that we mixed when we dumped the hot water into the cold water in our calorimeter. That is the temperature of the water at the instant that it was mixed, and that's what we'll use on the first part of our experiment for the data that we need from the graph. Is that number. That's the number that you need there. Now for the second part of the graph, or the second part of the experiment, if we want to figure out how much salt we're going to need to use when we engineer our hot packs and cold packs next week, what we're going to do is take our data. We're going to need to do this twice, and I'll show you an example of one of them here. So for your calcium chloride, you'll have 3 data points. You'll have a mass of salt used, and you'll have a change in temperature that salt affected. So we're going to highlight those 3 data points, and we have them set up in a mass in one column and change in temperature in another column. And we have the mass in the first column, so it appears on the x-axis, and we have the change in temperature in the second column, so it appears on the y-axis. And again, we'll go up here and click Insert, and we will click the same scatter plot with only markers that we used earlier, and we'll get a graph that has just 3 data points on it. Again, we may want to add some axis titles and we definitely want to add a trend line. So you can change a lot of that information there. So you have to change the axis titles here, apparently, on the online version. On the bottom, we are going to put mass in grams. And get rid of that. On the y-axis, like a rotated title, we are going to put change in temp in degrees Celsius, and my title is something like mass versus temp change, and this would be the calcium chloride, CaCl2. This will be the calcium chloride graph, and we will turn on the trend line and turn on the equation values so that we can get an equation for that chart. So this equation we will use in the second part of the experiment. You're asked to answer a question when you're filling out your post lab for this experiment. You're asked to determine how much of each substance, the calcium chloride and the ammonium chloride, you're going to need to use next week to change the temperature of the water by some amount. So we want to get our hot packs to about 70 degrees Celsius, and we want to get our cold packs to about 5 degrees Celsius. So one thing I want you to understand is from this graph, the y here, what the y indicates, or what the y represents, is the change in temperature. So when you're trying to design this cold pack next week, you got to think about what change in temperature you want to effect in that cold pack. So you have to think about what temperature the water is going to be in the cold pack or hot pack when it starts, or before it has water mixed into it. And it's going to be about room temperature. We're going to assume that it will be about room temperature coming out of the pipes and the plumbing in the building. It might be a little bit cooler than that, but by the time you get done and everything's equilibrated, it will probably be room temperature anyways. So we're going to start at room temperature, and we're going to try to reach 70 degrees Celsius in our hot pack. And we'll be starting at room temperature, and we're trying to reach 5 degrees Celsius in our cold pack. And you want to calculate how much of a change that is, how much of a difference that is. And you can take that amount, that change or that difference, and plug it in for y. And by solving for x, you will have determined how much salt you need to use next week to get your hot pack to 70 degrees and to get your cold pack to 5 degrees. Now the trick is to make sure you use the right graph for the right substance. You'll make a graph for calcium chloride, and you need to use that only for calcium chloride. And you'll make a graph for ammonium chloride, and you will make only for ammonium chloride. So that is how to make the graphs that you need to make for the calorimetry experiment. All four types, or all four graphs, can be made using the video discussion we had here. And if you need any help, you have my email. Please feel free to ask.